Welcome to AulaUE. Today we're going to talk about hypothesis testing. Let's suppose that we want to solve the following problem. The mean of a bacteria population is x bar equals 10 and a random sample of 20 specimens is studied. Show that this population is not normally distributed with parameters 14.3 with alpha equals 0.05. Okay, first of all, I'm going to copy the given data to have a summary of the values that we know. X bar is equal to 10, N is equal to 20, alpha is 0.05, and we want to show that this is not normally distributed with parameters 14 and 3. So let me just remark that sigma is none and it's equal to 3, and hence we have to employ and work with a normal distribution for this problem. So when we compute the test statistic, we need to use the formula for the normal statistic. Okay, let me just start with the first step, that is going to be to define both the null hypothesis and the alternative one. Okay, we just need to read once again the problem and see that we want to check that the population is not normally distributed with parameters mu equals 14 then sigma equals 3. So we want to test if our mean is going to be equal to 14 or different from 14. So the null hypothesis is going to be mu equals 14. Recall that the null hypothesis always contains the equal sign. And the alternative one, it's going to be mu different from 14. Okay, once that we have stated both hypotheses, the second step, it's going to be to compute the test statistic. And as I said, since sigma is none, we have to employ the test statistic for the normal distribution, and that's the reason why we call it Z. Z, it's going to be x bar minus mu divided by sigma over square root of n. So for this particular example, it's going to be 10 minus 14 divided by 3 over square root of 20. If we operate a little bit, we find out that Z, it's going to be minus 5.96. This is the value for the test statistic for this particular problem. Okay, let's go on with the third step. Step number 3, it's going to be to define the rejection region. Let me just remark that in order to define the rejection region, we need to realize that for this particular example, the alternative hypothesis, it's a hypothesis with two different possibilities, right hand side, left hand side. So it's going to be a two-side test. Okay, so we need to compute the value of alpha halves. Since alpha is given, it's equal to 0.05, alpha halves is just 0.025. Okay, let me just remark this important fact. H1 is just mu different from 14, so it's a two-side test. Okay, we have two different parts for the rejection region. Okay, so what we have to do is just make a sketch of the rejection region. Let me just plot it here. We just draw the normal distribution curve, and we just need to calculate the values for the rejection region. These two values are just set of alpha halves, and for this particular example are just set of 0.025 in the right part. It's going to be 1.96, and the same value with negative sign for the left part. Let me just remark that set of 0.025 is just equal to 1.96 because that is the value that leaves the probability of 0.975 from minus infinity up to this given value set alpha halves. Okay, this is something that we have studied in detail in previous videos. Good, so the rejection region is just from minus infinity up to minus 1.96 and from 1.96 up to plus infinity. So I just plot it here in blue. Okay, let me just put it, this is the rejection region. Very well, we just noticed that we have alpha halves probability in each part of the rejection region, so both together of course are equal to alpha. the given value, 0.05. Good, now we just have to check if the test statistic falls inside the rejection region or outside. In this particular case, since the test statistic set is equal to minus 5.96, which is smaller than minus 1.96, the value of minus z alpha halves, then the test statistic is inside the rejection region, and hence we have to reject the null hypothesis for this example. Okay, if we reject the null hypothesis, we just state that our population is not normally distributed with a mean equals to 14, as of course required to show in the exercise. And with this, we just follow the conclusion. Okay, I hope you enjoyed this video and see you in following videos.